Okay, section 5. Where did our moon come from? We've already seen that the density of the moon is oddly low. It doesn't seem to fit in with the other objects in the inner solar system like Mercury and Venus and Earth. It has this very low density, and that's really the key to the current theory of where the moon came from. Let me just point out, though, before we get into that theory, that in the past there were many other theories that just didn't pan out. For example, some moons form with their host planet. They just form from the same ball of material at the same time. We think, for example, Jupiter's large moons probably formed with Jupiter. They were kind of leftover debris and gravity clumped them together into spheres. Well, the problem here is that the moon is made of different things than the Earth. It doesn't match up in terms of the composition, or the density for that matter, so that doesn't seem to work. Another thought, probably the majority of moons in our solar system are really just captured asteroids. They were just flying along, and they got too close to a planet, close enough that the planet's gravity took hold, and they happened to be at the right angle and the right speed to go into orbit. Lots of moons come about that way. Mars's 2 moons, for example, are definitely captured asteroids. However, our moon is really big compared to the size of the Earth, and the physics of that is extremely unlikely. And you still would have to explain where the moon came from. What was it doing hanging out in the inner solar system? That one doesn't seem likely. One interesting theory that came about long ago is that a molten Earth was spinning so fast that a chunk of it flew out into space and became our moon. Well, that's a clever thought, but again, the physics doesn't work out because there's no way we were spinning that fast. However, there was one good thing about that theory, is that if the part of the Earth that came off was from our mantle, which is not nearly as dense as our core, it would explain the moon's low density. Well, that led to the current theory. And the currently accepted theory you can just call the impact theory. And that theory was that as the Earth had just formed in the solar system, it was hit by a planet-sized object. A planet probably the size of Mars. It even has a name. They've been calling it Theia. So Theia smashes into the Earth, but here's the key. The computer simulations show that this is possible, but only with a glancing blow. If it hits too hard, it just destroys the early Earth. But instead, it chips off a piece of the Earth. Theia itself is basically destroyed, and some of Theia and some of the chipped off Earth become our moon. Now that may sound crazy to you, but physically it's possible. Computer simulations show that it's not only possible, but it matches the composition and density of the moon. So that's why we think it's a good theory. So pretty interesting stuff. And again, because it chips off part of the Earth, it's not taking the iron core. It's not taking the dense part of the Earth, just the upper mantle and crust where it's less dense. And that's why it seems to match. And by the way, just an interesting thought. If this really did happen billions of years ago, it's a pretty good question of whether there's any sign of that impact left. Well, if there is, we know where it is. There is a dent in the Earth that could possibly indicate where the moon got chipped off. That dent is what we call now the Pacific Ocean Basin. Interesting thought. We don't know that for sure, but it is interesting because that was a long time ago in the molten Earth. Who knows? Who knows? So I just want to throw that little idea out there. And that's it for this very short section.